All right, hi guys. At this point, you should have watched the little tutorial about the spectrophotometer. You should have watched the little tutorial about the micropipetter, and you should have read about the procedure, and you should have watched the video about having made the little data table in your lab notebook about what's going to go into each of your two test tubes. So now we're actually ready to generate data, and remember the purpose of this whole lab is for you to learn how to generate data. There's not as much data analysis as there is with the DISC lab. This is about how do you use a spectrophotometer and how do you use all this equipment, so that if you do want to use this kind of stuff in order to do your inquiry project that you'll do later on in the unit, that you have the proper techniques in order to do so. So at this point, we are ready to start building our two test tubes, our substrate test tube and our enzyme test tube, using the stuff that you wrote out in your procedure. And we're going to build these two test tubes separately, and then we will combine them, and as soon as we combine them is when our reaction begins, and so that's when we have to start timing our reaction and collecting the data that it says. And so we are going to begin by labeling our test tubes, because if you put something in the wrong test tube, you're going to end up with starting your reaction without getting a color change, and it being finished before you even get to a spectrophotometer, or getting no color change at all, or something silly like that. So you want to make sure that you keep straight what is your enzyme test tube and what is your substrate test tube. Both of them are mostly water, and so it's easy to start by saying, okay, I need to put 6 mils of DI water in your enzyme test tube and 7 in your substrate test tube. What's important is that you use DI water for this. Don't use tap water. It will mess with your results, and so we want to make sure that we use our jug. So to measure our water, you're just going to use your graduated cylinder. And so I'm going to start by filling my substrate test tube with 7 mils. And you do need to be fairly precise with this. Very often, as you guys know, I tell you that you don't need to be precise in biology, but this is one of those times when you need to do it properly. And so right on down to the last drop, if you want to get a dropper, in order to make sure that you do it properly, you can. I've got 7 mils, that's going to go in my substrate tube. You guys are going to actually have test tube racks, not cups, because I don't want these to fall over. And then I'm going to get 6 mils for my enzyme tube. Okay. And enzyme. And we're good to go there. The only other thing I need for my enzyme tube is my enzyme. And so I will have wooden test tube racks set up in a couple of different locations, clearly labeled with what's what, because I don't want you guys to get the wrong stuff. And that's really the only way this lab can go wrong. So here's your your enzyme, your peroxidase. It's clearly labeled peroxidase, and it tells you how much of it you need in case you got confused. You need 1.5 mils. In order to measure 1.5 mils, we're actually going to use a graduated pipette. This is not a micropipette, but a graduated pipette has these little lines on it that tell you exactly what the measurements are. So there's 1 mil, and then right there's 1/2 mil. You can see the little 0.5. So you have to do, there's no measurements up here in the bulb. So you're going to fill it up first to the 1, and then the second time to the 0.5 in order to get your 1.5 mils, and then you'll put that in your enzyme container. And so when you're not using the stuff in the test tube, leave it capped, mostly because it really stinks. All of it really stinks, and so you want to just kind of keep it capped so that the room doesn't smell awful. It's going to smell awful anyway, but let's try to keep it down. And so you'll get, squeeze your little graduated pipette in, slowly release until you get up to the 1 mil mark. Once you get to the 1 mil mark, pull the tip out, and then you can say, okay, that's my enzyme, put it in my enzyme tube. And then we do the second time only up to our 0.5 mark. Excellent, and that's enzyme. Done. Don't take this with you, leave it here Otherwise, we end up with cross-contamination because people bring them from other places in the room. Okay, good to go there. Enzyme is done because all that had to go into that enzyme tube was the 6 mils of the DI water and the 1.5 mils of peroxidase, and that one is finished. Notice a total volume is 7.5 milliliters. We actually have a total volume of 7.5 milliliters in the other test tube as well. We're going to use that to kind of check our work before we combine them to begin our reaction to make sure we have the right number of amounts of stuff. So now we need to put our glycol and our hydrogen peroxide in our substrate tube. Okay, that makes sense because what we're trying to break down is that H2O2, and then the glycol is going to take the oxygen gas from this reaction and turn it into a color. So that's what we have to do next. So I'm going to take, just to make sure I don't goof, I'm going to take my enzyme tube and set it aside so that it's easier for, well, because I have to focus on several things right now. So at the glycol station, again, it is very clearly marked. You need 200 microliters of glycol. If we look on our micropipetter, it's set to 100, which means I need 2 doses of this stuff. So I'm going to take my stopper out, depress my plunger to the first stop, submerge the tip, release my plunger, pull it out, come over to my substrate test tube, and now I depress to the second stopper just to make sure I get it all out of there, and I'm going to do this 2 times. So that was 1. I'm going to depress to the first stop, submerge, release, and then to the second stop here to make sure I get all of my glycol. So that's that. Again, you're going to leave your micropipetter with the glycol so we don't get any cross-contamination. Next, we're ready for our hydrogen peroxide. And again, these are going to be in different places around the room just to make sure you don't get confused. Here we need 300 microliters of our hydrogen peroxide. Take the cap off. Same technique as before. Press down to the first stop, submerge the tip, pull up, or allow it to come up. Okay, into my test tube. 1, go to my second stop to get it all out. 1 dose. 2 doses. And 3 doses. Okay, done. Put the stopper back on. Leave the micropipetter where you found it. At this point, we are ready. Now, there's only going to be 5 spectrophotometers around the room, and so you don't want to start your reaction until you and your group has literally claimed one of them and you're standing in front of it, because you are going to keep record for 5 minutes of how these numbers are changing over time. And so if you looked at step 4 in your lab notebook, it said to record the color, which is the absorbance, at 1 minute increments. I do think that we can probably do better than that because we have the spectrophotometer. And so I think that you're probably best to do it in 30-second increments rather than in 1 minute increments. It's just going to give you more points to plot, and I think that that will be useful. So you're going to collect data in 30-second increments. So, at this point, you have your 2 test tubes, and then you have also obtained your cuvette, okay, because this is the one that actually fits in your spectrophotometer. And so this is certainly a 2-person job, and so what I'm about to do, being that I am 1 human, is not going to be quite as graceful as what you're going to do. Bearing in mind that, and it tells you this in your lab notebook, the glycol can be a skin irritant, so you don't really want to get the glycol on your hands. It's actually very rare that somebody has a reaction to, or a skin reaction to touching glycol, but just on the off chance, the goal here is not to get it on yourself. And so when you have your test tubes, you're going to remember that you're going to have them actually in a rack. You're going to pour 1 test tube into the other. And the reality is it doesn't matter which one you pour into the other. But by leaving this one in a test tube rack rather than in a cup, you have much less of a chance of actually spilling it on yourself, and it's just safer that way. So you take one test tube and dump it into the other as soon as the contents meet your reaction began. So somebody needed to start timing at that moment. Once you have combined them in this test tube, the only way you're going to be able to get absorbance values is by then putting it into the cuvette. you can see I'm already starting to change color. So then you pour it immediately into your cuvette. And remember, you're trying to get it up to the bottom of that dot. There we go. Keep this test tube out, because once you put the cuvette in your spectrophotometer, you're not going to be able to see what's happening. So it's kind of fun to be able to actually see the color change that the spectrophotometer is giving to you in numbers. Once you've got your cuvette, chances are good that you touched it somewhere beneath that dot. And if you did, you're going to use your Kim wipes. Remember, in the green box, this is not a Kleenex, it's a Kim wipe. It's special to wipe it off. And you're going to then insert this puppy in your spectrophotometer. So I'm going to walk us over to the spectrophotometer, which is here. Here it is. And I'm going to put it, oops, you will have, I don't have enough hands for this, you will have taken your blank out before you started this. And then you put your sample in your spectrophotometer. Okay, looks like that. Close it up. And then you're going to take a reading, this right here, every 30 seconds. So somebody's got to keep an eye on the clock and say 30 seconds, 30 seconds, 30 seconds. And you do that for 5 minutes. And again, the reason it doesn't really matter that we only have 5 spectrophotometers is because you actually only need the spectrophotometer for 5 full minutes. Once you're done, you take that cuvette out, put the blank back in it so that the next group can blank theirs. Right, remember making sure that you have 100% transmittance and 0% absorbance. So you want to make sure that you take that cuvette back out, you've put the blank back in, and then you're done. You're ready to graph your data and whatnot. Only other thing I need to tell you is that guaiacol cannot go down the sink, so I'll have a special waste container for the guaiacol, and then we have the district dispose of that in a safe way. So, oh, you know what, and I just realized that I did something really atrocious. Don't do this. I'm supposed to be on absorbance, and right now I'm on transmittance, and so if you switch over to absorbance, you're able to see these numbers as they change, and you can record that value. All right, I think we're done. That's it. Thanks for watching the video. Have a good day.